Hey everyone, we are doing Scholarship Calculus 2023, question 3a. Consider the curve defined parametrically by the equations x equals 2t minus 3t cubed, y equals t e to the power of t. Find the coordinates of any stationary points on the curve and determine their nature. I consider this question quite easy as a scholarship question, so it's almost level 3 differentiation, isn't it? Question. Now, so what they are asking you to do, you find the dx, oh sorry, dy dx, right? And then you find, so to find the stationary point, what do we have to do? A equals 0, isn't it? Yeah. So you have to find the t, that is a stationary point. Then to determine the nature of the stationary point, you have to go d squared y dx squared, right? So I just remind you, when you plug that t into this, if it is positive, what is it? That is a local minimum, isn't it? If that is negative, that's local maximum. And if that is 0, that's a point of inflection, isn't it? So we will find that out. First, we have to go dx dt, isn't it? Which is 2 minus 9t squared. And then dy dt equals what? T to the power of t, isn't it? Right. So hence dy dx equals what? Dy dt, which is t e to the power of t, times by the reciprocal of this, isn't it? Which is 1 over 2 minus 9t squared, which is t e to the power of t over 2 minus 9t squared. That should be 0. So, well, t e to the power of t must be 0, isn't it? So as you know, e to the power of t can't be 0. Therefore, t must be 0, isn't it? So when t is 0, what is it? Is that local maximum or minimum or point of inflection? So obviously we have to differentiate this again. So oftentimes, you guys just do this, and then you think that's a second derivative, but it's not. To get d squared y dx squared, you've got to times this by dt dx, isn't it? So that you can achieve d squared y dx squared, right? So I'm saying you have to differentiate dy dx, so which is this, right? And then times by the reciprocal of dx dt to achieve that. So let's do that. Now, to differentiate that, you have to use quotient rule, unfortunately. So say u equals t e to the power of t, and v equals 2 minus 9t squared. So u prime equals what? T e to the power of t, right? v prime is minus 18t. Okay, so therefore d dt dy dx equals, what is it? For u prime, which is p e to the power of t, 2 minus 9t squared minus uv prime, which is 18t squared e to the power of t over v squared, which is 2 minus 9t squared squared, isn't it? Right, that's not it. We have to times by, so to achieve d squared, d squared y dx squared, we have to go that one. So t, yeah, I just repeat this, plus 18 t squared et over 2 minus 9t squared times by, do you remember we have to multiply by reciprocal of dx dt, which is 1 over 2 minus 9t squared. 1 over, yeah. So 1 over 2 minus 9t squared, isn't it? Now, what I see here, yeah, well, the denominator is 2 minus 9t squared cubed, right? And then t e to the power of t, 2 minus 9 t squared plus 18 t squared e to the power of t. So obviously we have to plug 0 into t. Do you remember? When t is 0, that is a stationary point. So what is this is the question, is it? So obviously that becomes 0, isn't it? And that is 0 as well. Fortunately, denominator is not 0. So it turns out 0, which is a point of inflection. So I'm gonna say answer when t equals 0, it is a point of inflection. I just explained what a point of inflection is. So say I have a cubic, so from here to there, somewhere in the middle, so it is called concave down, and this is a concave up. So between concave down and concave up is called a point of inflection. Okay? Alright, I will see you next time. 안녕.